double integral over general region. What is the difference between over a general region versus over a rectangle? So here is the difference. I have a function y over x squared plus 1. And then this one is over this general region. The general region is on the xy plane, where x is between 0 and 4, y is between 0 and square root of x. This is no longer a rectangle due to the square root of x. X is between 0 and 4. When x is equals to 4, the square root of 4 is equals to 2. So y goes from 0 to 2. So here is what happened. The function y over x squared plus 1 can be represented by a piece of paper that you are holding up on your table, and then the xy plane is the table. So the shadow of the function is on the table, and then I am only interested in this region. So there is a space, a three-dimensional space between this region and your paper. Your paper is above the table, and then this region is part of the shadow. So there is a three-dimensional space between this region and your function and your paper, which is the function. So that space, we call this the volume. All right. Okay, how do we find the volume then? To find the volume, we will have to follow the double integral. This double integral, we can only do a dy dx. So let's do it. Double integral y divided by x squared plus 1, and then we have dy dx, and then x is between 0 and 4, x is between 0 and 4, y is between 0 and square root of x. Let's get started. So y is a variable that I will just do the y only. So this will be integral from 0 to 4. The integral of y is 1/2 y squared divided by x squared plus 1, and then y goes from 0 to square root of x, and then don't forget the outer integral, the dx. And then we will just do the plug-in. Okay, we will just do the plug-in. We plug in, we have, let's do the plug-in right here. So I'm going to save myself a little bit more space. Can we do that? Yep. So that is equal to, from 0 to 4, plug in a square root of x to y squared. I have 1/2 x divided by x squared plus 1. This is a plus 1, and then minus 1/2, and then multiply a 0 divided by x squared plus 1, and then we have a dx. So the 0 just makes the whole thing becomes a 0. And then the next step, I will pull the 1/2 out. We have 0 to 4, x divided by x squared plus 1, x squared plus 1. Hey, this is a u substitution. U is equals to x squared plus 1 just x squared plus 1, and then the du is equals to 2x dx. The x is get rid of the x on top. 1 over 2x du is equals to dx. U of 4, that is a 4 squared plus 1 equals to 16 plus 1. And then u of 0 is 0 plus 1, which is equals to 1. Okay, I'm going to move this down so I can, so I can show some work right there. So I have 1/2 integral u goes from 1 to 17. Before I move on, I have to remind you that after you change the x in terms of u, sometimes, not always, sometimes the upper limit is less than the lower limit, which is fine. As long as the arithmetic is right, you are okay. What's next? X divided by u, and then the dx. So this is a change of variable in case you haven't done that for a while. So that dx, this is what dx equals to, goes here. So we place that dx. You have 1 over 2x and then a du. The 1/2 you can pull out, the x is cancelled, so you have 1 over 4, and then integral from 1 to 17, and then 1 over u du, which is an ln, right? So that is equals to 1 over 4 ln absolute value. I would just say is optional because once you plug in 1 and 17, they are positive anyway. So that is equals to 1 over 4 ln 17 minus 1 over 4 ln 1. But ln 1 is equals to 0. So the answer is equals to 1 over 4 ln 17. And then you box this. What is this represents? This represents the volume. The volume of what? The volume between this function and its shadow on the xy plane. So the function is just hold up a piece of paper right now on your table. So that paper is this function, and then the paper covers some space on the table, right? That is the space that we are looking for. And there is a three-dimensional space between your table and this piece of paper. That is the volume. The volume is 1 over 4 ln 17. Now, there is another question that I must answer is, can we swap the dy dx? Can we do a dx dy integral? Let's drop this integral down. So the question is, can we do this integral from, okay, let's do a double integral. And then we have the function y divided by x squared plus 1, and then we have a dx dy, right? Is this correct? So for the dx, x will be from 0 to 4, and then y will be from 0 to square root of x. Is this correct? This is not correct. Do you know why? Because the volume is supposed to be a quantity like that, but if you do a dx dy, you will plug in a square root of x at the end. So that means your answer is not going to be a constant. The answer is going to be something that has an x in it, which is incorrect. So for rectangle, when these two are number x and y between two numbers, you can swap the dx dy. The only difference is the difficulty of the integration. You will get the same answer. But for this type of general region, especially if you have if y is between 0 and a function, then you cannot just swap the dy dx and the dx dy. Alright, so that is the end of this problem. If you like the way I explain double integral over general regions, thumbs up for this video. Subscribe to my channel for more contents like that, and I will meet you all in the next one. Signing out.